Hi guys, today we will be talking about advanced data model. Advanced data model is based on initial simple data model with addition of couple of concepts that we will talk in details today. I'm going to minimize my video and then we're going to go through the presentation. Advanced data model is covered in chapter 5. Please base your reading on the slides. You're welcome to read the entire chapter, or you can read only material covered in this lecture. We're going to start from We're going to start from the basic review of the last lecture. So last lecture, we talked about entity relationship diagrams. We looked at many examples on how to build those entity relationship diagrams. And those were simple entity relationship diagrams. Entity relationship model it has various components to that, including entities, attributes, and relationships. Well, we talked about different entity types, strong and weak entity types, and we talked that relationship between strong and weak entity types is called identifying relationship. We also talked about different attributes, different types of attributes. We talked about relationship, and we also talked about bidirectional relationships. So, for example, if student and classes have a relationship, it means that it's relationship from the student to class and from class to student. And here's an example. Student is identified by student ID, name, and address, and those are entity attributes. We talked about different attributes types, different classifications of attribute types. So those are simple valued, multi-valued. Multi-valued are those that have multiple values stored in the same attribute. We also talked about simple and composite attributes. Composite is an attribute that consists of multiple simple attributes. And we also talked about unique identifiers too. We talked about different types of relationship cardinalities, can be one-to-one, one-to-many, or many-to-many relationship, and relationship degrees, where it can be unary, binary, ternary relationships based on a number of entity types involved in specific relationships. We talked about attributes on relationships. So similar to entities, attributes can have relationships too. And we talk about specific case, associative entity that is somewhat hybrid between entity and relationship. It has property of both. We also practiced a lot on how to read relationships. And in this case, for example, invoice has invoice lines, and if the question arises, is there a limit of invoice lines per invoice? We read in relationships from invoice to invoice line, and we look at the character that specifies many on the invoice lines. So the answer for the question would be no, there is no limit on invoice lines per invoice because we don't see this little numbers there, and it's one-to-many relationships. And if, for example, it's going to be number of invoice lines limit per invoice, we will see a number down to this many symbol on near invoice line entity. All right, so those were simple entity relationship concepts and simple entity relationship diagram blocks. Those were entities, attributes, and relationships. All right, today we will talk about more advanced concepts that include that are part of advanced or extended entity relationship diagram. So we'll understand the differences between subtypes and supertypes and attribute inheritance. Subtypes and supertypes are components of extended entity relationship diagram. We will describe attributes and relationship inheritance as a main part of entity relationship extended diagram. We'll talk about total and partial specialization rules that defines specifics between relationship of subtype and supertype. Further down, we'll talk about disjoint and overlap constraints. And another concept of extended or advanced entity relationship diagrams are entity clustering. So entity clustering helps us to group separate entities together to simplify a diagram. So diagram can consist of clusters or specific entities, and clusters added to simplify a specific diagram. All right, so let's get to the lecture, and we're gonna start from um, the components or concepts of extended or advanced entity relationship models. Those two terms are equally used, extended, advanced. So it also can be called EERD, ERD. All of those terms are used interactively. So when it comes to enhanced entity relationship model, we add three different new concepts. We add a concept of supertype, a generic or common entity type that has relationships with one or more subtypes. And we introduce a concept of subtype. It's a group of specific entity types that has some distinct attributes um, specific for them, or can have attributes of supertype. And along with those two, we will talk about attribute inheritance, where subtypes can inherit both attributes and relationships of their supertype. So let's look at the example here. So we have a supertype vehicle and we have multiple subtypes here: motorcycle, car, bus, truck, and there's different varieties of those. You can look at this picture, and we have single trailer else, we have single trailer of 6 or more else, and so forth. So all of those are subtypes of supertype vehicle. Let's look at another example. Let's try to identify subtypes and supertypes based on the following diagram: classification of animals. You guys can pause the video here and try to do it yourself. All right, and then I'm gonna do it for you guys. So vertebrates is a supertype for warm-blooded and cold-blooded animals, and in turn, warm-blooded animals is supertype for mammals, birds, and fish, and cold-blooded is a supertype for reptiles and amphibians. Warm-blooded is also a subtype of vertebrates, and cold-blooded is subtype of vertebrates too. So very simple, just something to get us started on the topic. All right, so let's start from the definition here. So supertype is a generalized entities and represent higher level of abstraction of related entities. We did talk about abstraction concept, and we're just combining different types together to represent a specific supertype. It's also very important to understand that supertype has specific common attributes to its own, and those attributes are shared by all the subtypes. So for example, in the database where vehicle is supertype, vehicle might include attributes of vehicle ID, make, and model, and those are attributes specific for entity of supertype, and they're common for all the subtypes. So that is supertype, and the key takeaway from here is the supertype 1 generalized entity for future breakdown into subtypes. And this generalized entity also has its own attributes. Okay. So for the subtypes is a specific entity that represent a specific categories or types within a broader or more generalized supertype. Subtype inherits attributes and relationships from its supertype, and it means we're going to talk about inheritance in a little bit, but it means that subtype has the same relationships and attributes as its supertype. However, a subtype can have a specific attributes to its own that are not shared by a supertype. So, for example, supertype vehicle and subtype car. Car has number of doors that is specific for this subtype, and another subtype is truck, and it has payload capacity that is also specific only for trucks. Neither vehicle, neither its supertype vehicle, nor another subtype car have those attributes. Okay. Um, so here's an example of entity subtypes and supertypes. In this example, we have a supertype employee that has its own attributes specific for employee supertype that are also shared by three different subtypes. And subtypes of employee entities are different employee types. So hourly employee, salaried employee, and consultant. As you can see here, that each of those subtypes has um, all the attributes that their supertype employee entity has. However, they have also their own specific subtypes that are only specific for a certain subtype. For example, hourly employee has hourly rate, salaried employee has an annual salary and stock options, and consultant has also specific attributes, contract number, and billing rate. So um, again, key takeaway from here is supertype has attributes that are shared by all subtypes. However, subtypes can have their specific attributes only available for a certain subtype. So look at the same example, just in the diagram. While employee has employee number, which is a unique identifier, and name, address, and date hired, and hourly employee, salaried employee, and consultants have their own specific attributes. Please note that we do not repeat attributes on the subtype level because we know that those are inherited by subtypes through a supertype. So let's look at the example, and next slide has those questions answered. So I want you guys to practice at home in reading those diagrams. So I'm gonna go through this example one by one, those questions, but you guys can practice on your own. You can look at this slide and try to answer a question, and then go to the next slide and check your answers. So here, like, I mean, it's the same slide, just has multiple variations of it. So let's look at the first question. And again, we just need to identify subtypes and supertypes. So what is our hotel room supertype? So we need to find hotel room here, and it's down on the second level. And if you go up from the hotel room, you know that the supertype for hotel room is an accommodation. What is a hotel's room subtype? So when we talk about subtype, we go down from hotel room, and we can see that it has different subtypes, suite and standard room. What is accommodation subtype? So let's look at accommodation entities that is on the top of our food chain. Does it have a supertype? No, it doesn't. So accommodation doesn't have a supertype, so there's no supertype associated to that. What is suite subtype? Suite doesn't have subtypes. There is no lines going down from suite, so it just doesn't have subtypes. What is a standard room supertype? We look at the standard room and go one level up, and standard rooms supertype is a hotel room. What are vacation rentals subtypes? So vacation rental is a supertype, and it has apartments and apartment and villa as subtypes. Please practice. There will be questions like this on the exam and on the test. So I want to make sure that you guys can read those diagrams. And the next slide explains those answers for you. Uh, let's look at the concept called inheritance. In the beginning of this lecture, we briefly talked about inheritance. Before we apply inheritance to subtype and supertype concepts, I want to explain you inheritance in the broader term. For those of you who had programming classes, they're probably familiar with inheritance. Inheritance is an ability of certain characteristics and properties to be passed down from higher level category to the subcategories. So in this case, we have um, in this example, we have two higher level categories, parent 1 and parent 2, and they both have characteristics brown eyes. And in this case, those characteristics pass down to the subcategories which are children. So children both have brown eyes here. Very simple. Inheritance is in passing certain characteristics down from higher level category to the lower level. So let's apply this concept to our subtypes and supertypes, and then we're gonna talk about attributes inheritance and relationship inheritance. So super subtypes inherits both attributes and relationships from supertype. When it comes to attributes inheritance, that means that attributes of supertype entities are inherited by its subtype. So, for example, supertype vehicle has attributes make, model, and year, and subtypes car and truck inherit those attributes, as they also have make, model, and year. Relationship inheritance is very similar to what we just discussed, but it talks about relationships. So that means that every relationship supertype participates in propagate down to its subtypes. So for example, if supertype vehicle has one to many relationship with manufacturer, both car and truck have those one-to-many relationships with manufacturer too, and they inherit those relationships via vehicle subtype, supertype. Let's look at the example so we can discuss it a little better. So in this case, relationships at supertype level indicate that all subtypes will participate in this relationship, and the specific instance of a subtype can have also unique relationships only for this certain subtype. So if you look at the top of the picture, we have a supertype with unique identifier with shared attributes and relationships that the supertype has. They are available for all instances of the subtype. And looking at subtype 1 and 2, both of those have unique attributes only specific to those subtypes. And subtype 1 participates in relationships that are only specific for this subtype. Neither supertype nor subtype 2 have those relationships. And when we're talking about supertype, it's a generalized entity type for two of those subtypes. So this is a very general example. Let's get into specific example. So let's look at the subtype, supertype relationships in the hospital. We have a supertype patient that has a relationship with, it's cared by responsible physician, or responsible physician cares for patient. So that is a relationship on the supertype level. And um, patient supertype has attributes. It's patient ID, patient name, and admit date. Those attributes are specific for patient supertype, and they are inherited by both subtypes. Outpatient and resident patient are two subtypes of the parent supertype. They inherit all the properties or attributes of the patient. So in this case, outpatient and resident patient will both have properties, patient ID, patient name, and admit date. And those are not listed under subtypes, but they are inherited via patient supertype. In this case, also outpatient has its own specific attribute, checkback date, and resident patient has a date discharge. So those are attributes specific for each of the subtypes. And resident patient is assigned relationship with bed. So resident patient can have assigned bed, and it's one-to-one relationship. You can it's also mandatory on one side and optional on another side. So not every bed can have patient, but every patient has assigned bed. And those relationships with bed is specific for resident patient. Neither patient supertype nor outpatient have those relationships. So again, is responsible physician relationship with patient is inherited by both resident patient and outpatient, but bad relationship with bed is only specific for one subtype, resident patient. Right, let's move on and let's try to read this extended diagram. Similar to the previous scenario, I'm going to go through this example in details, and then you guys can practice on your own. So first question, and we're trying to practice our knowledge of inheritance here. Does employee have PL name attribute? So let's find this PL name attribute first, and it is an attribute of person. And person is a supertype that has employee and student subtypes. So does employee have L name attribute? The answer is yes. PL name attribute is inherited by employee through its supertype person. Next question, does student have grad thesis attribute? So student is a subtype of person, and student has two subtypes on its own. So it's a supertype for graduate student and undergraduate student. Grad thesis attribute is an attribute of the graduate student, of student subtype. And as we know that subtypes inherit attributes from the supertype, but supertype doesn't inherit attributes from the subtype. So in this case, graduate thesis is a specific attribute for the graduate student, and student supertype does not have this attribute. Next question, does administrator have PF name attribute? So let's find administrator. Administrator is a subtype of employee. An employee is a subtype of a person. A person supertype has has attribute PF name, and this attribute is inherited by employee, and this attribute is inherited down by administrator from employee. So it's inherited from person to down to employee, and from employee down to administrator. So this is an example of multiple level inheritance for the attributes. So the answer to this question is yes. PF name attribute is an attribute of administrator entity. Next question. Does person have employee hire date attribute? So employee hire date attribute is an attribute, specific attribute of employee. Employee is a subtype of the person. So person is a supertype of employee. And as we know, supertype does not inherit attributes from subtype. It's vice versa. Subtype inherits attributes from supertype. So the answer to this question is no. Person does not have employee hire date attribute. Next question. Does professor have employee hire date attribute? Let's find professor. Professor is a subtype of employee. Employee has employee hire date attribute. So this attribute is inherited by employee subtype professor. The answer to this question is yes. Does graduate have a student major attribute? Graduate is a subtype of student. So student is a supertype of graduate. Student supertype has an attribute, student major, and this attribute is inherited by graduate entity. So the answer to this question is yes. Graduate has student major attribute. Please practice. It's really simple. You just need to get yourself a little more familiar with that. All right, so this is an answer for this, and let's practice more. We have more questions here. So does tester have a barcode attribute? We're trying to do the same thing there here as in the previous example. So does tester have a barcode attribute? Let's find tester. Tester is a tester is an entity that has a relationship with electronics. Electronics is a subtype of product. So product has a barcode and electronics has a barcode. So testers is just an entity that has a relationship with electronics. It's not a subtype of electronics. So the answer to this question is no. Can outwear be produced by multiple manufacturers? So let's find outwear, and it's under the bottom. Outwear is an attribute of the clothing, or attribute, or outwear is a subtype of clothing. Clothing is a subtype of product. And product has a relationship with manufacturer. So one product can have many manufacturers. So we are reading the relationship from product to manufacturer. And on manufacturer, we have on manufacturer entity, we have many and mandatory. So product can have many manufacturers. And since those relationship with manufacturer are inherited by product subtype clothing and inherited by clothing subtype outwear, the question is yes. Outwear can be produced by multiple manufacturers. Can outwear be tested? So we are looking here at outwear, and outwear has specific attributes, but it has no relationship with testers. And testers is a specific entity that is related only to a subtype of product. So testers is not a relationship that is on the level of closing or level of product. So it is not inherited through subtypes. So out where sub supertype is closing and closing supertype is product, and neither of those have relationship with testers entities. So the answer to this question is no, outware cannot be tested. Does outware, next question, does outware have color attribute? Let's find color attribute. Color is an attribute of closing, and closing is a supertype of outware. An outware is subtype of closing. So all the subtypes inherit all the properties of supertype. In this case, supertype has color attributes, so subtype outware also has color attributes. So the answer is yes. Outware can have color attribute. Next question. Can manufacturer produce multiple electronics? So manufacturer has many-to-many relationship with product. So manufacturer can produce many products. And electronics is a subtype of product. So it inherits all the relationships that product has. So manufacturer can produce multiple supertype products. Subsequently, manufacturer can produce multiple electronics. So this relationship is inherited by electronics subtype. The answer is yes. Now, next question. Do types have type attribute? So let's find type attribute. Type is an attribute of electronics. And electronics is not a supertype of TOPS. In a matter of fact, it has no relationship with TOPS. So TOPS does not have type attribute. Next question, does outware have barcode attribute? So let's find barcode attribute. It's an attribute of supertype product. So product has a subtype of closing. So closing inherits barcode attribute from product. And outware is a subtype of closing, so it inherits the same attribute from its type entity, supertype entity closing, that in turn inherited from its supertype product. So it's multiple inheritance, but the answer to this question is yes. Outware inherits barcode attribute from 2-level up subtype product. Okay, please practice and it's gonna get a little better for you and you'll be able to understand it. So let's move on. And those are answers for those questions. So now we talked about attributes inheritance and relationship inheritance. Another very important concept of subtype and supertype, well, actually two important concepts are generalization and specialization. Generalization is a process of making more generic entity types based of existing many types. So it's a process of generalization, one entity out of existing similar entities. Specialization and generalization is a bottom-up approach. So we get multiple entities and we're trying to see what is common for all those entities. Specialization is a process of defining subtypes based of a specific super type. It's a process of making specialized entities based on the common one super type. So it's top-down approach. It's classification of existing general concept down to specific concepts. Let's look at the example. So in this case, this is a generalization example. We have three different entity types: car, truck, and motorcycle. And they all have some common attributes that includes vehicle ID, price, and engine displacements, and also vehicle name. By the way, what kind of attribute is vehicle name? Can pause here. Right. I hope you all answer that it's a composite attribute that consists of make and model. So there's also specific attributes for car, number of passengers, and truck, capacity, and cabin type. Motorcycle doesn't have any specific attributes. So in this case, we can create a general entity vehicle that has all those attributes. Now, that is example of generalization. So looking at multiple entities and trying to get common characteristics or properties or attributes out of them to put them on one level of supertypes. So that's generalization. Example of generalization, in this case, we created a vehicle supertype with three characteristics that are common to all subtypes. And now we have a car and truck. And all the attributes are shared of the vehicle supertype are shared by truck and car. Well, car also has its specific attributes and truck does too. Now, we had 3 and we get to 2. What's happened to vehicles? What's happened to motorcycle? Well, motorcycle doesn't have any specific attributes. So we don't have a subtype for that. Unlike truck and car, they have their specific attributes, so there are subtypes. So if there's nothing that specifically identifies an entity other than general attributes, we don't create a subtype for this entity. In this case, is motorcycle. All right, so that's generalization example, and now let's talk about specialization. The specialization, remember, it's a top-down approach. We have a general entity that we deal with, and we split that into multiple special subtypes. So look at this example. That's a part, and part has part number, description, quantity, and location. It also has a routing number. Routing number only applied to specific parts that are manufactured parts. We also have a supplier attribute, by the way. By the way, what type of attribute is supplier? Can pause here. And hopefully you answered correctly. So supplier is multi-valued composite attribute. It has multiple values, supplier ID and unit price, and a part can have multiple suppliers. So it's multi-valued composite attribute. We looked at some of those examples in the last lecture. So back to specialization. So we can get specific subtypes out of the part that is a manufactured part that only has a routing number. There's also a supplied part there's a part that is supplied to the specific warehouse, and this part has a supplier ID. At the same time, part number, description, and quantity on hand and location are common attributes for both manufactured and purchased parts. Let's see how we generalize, how we specialize parts into two different subtypes here. And we have a part as a supertype that has 4 different attributes. We have two distinct subtypes, manufactured part and purchased part. Well, purchased part, they're missing some attributes here, but purchased part has attributes too. So manufactured part and purchased part are subtypes of the part supertype, while at the same time, purchase part have a relationship with a supplier through supply schedule. It's very similar to what we looked before. And purchase part is the only subtype that has suppliers. So those are relationships specific for certain subtype that are not available for other subtypes like manufactured part, or those relationships do not exist for supertype part. All right, so that was specialization and generalization, two very important concepts. Now, let's talk about two more important concepts. We're going to talk about the rules. We're going to talk about specialization rule. Specialization rule applies to subtype and supertype relationships where subtype where subtype is can be only. Sorry, guys, I gotta stop for a second. Sorry, apologize. All right. So, total specialization rule deals with how many instances of the subtype is available for a specific supertype. So in this case, total specialization states that the supertype has to be either either instance of one supertype or another supertype, but cannot be both. So for example, patient must be either an outpatient or a resident patient. So there is no other types of patients exist. So there is no more patients outside of this classification. So there is only outpatient and resident patient. There is no other classification exists. So that's total specialization. When our diagram represents all the potential cases of subtypes. So patient cannot be anything within this gradation of patients. Patient can be either outpatient or resident patient, and nothing else exists. So no other types of patient exist, and that is what we call total specialization rule. When subtype must be either one must contain both subtypes that are available within a certain diagram or certain model. So it's represented as a double line on the diagram. And further down, we're going to talk about more more concepts, but in this case, patient can be only outpatient or resident patient. No other patients exist. No other types of patients exist. Well, there is also a partial specialization rule. A common example for partial specialization rule is our vehicle. When we have a super type that can have two subtypes, in this case, car and truck, two or more subtypes that are represented in diagram. However, other subtypes also exist. In our case, vehicle can be truck, car, or motorcycle. And motorcycle is not implemented in this diagram. Vehicle can also be different types of trucks. So vehicle subtype is not limited to only two vehicle supertype is not limited to only two subtypes represented in this diagram. So that is an example of partial specialization rule, and it is represented as a single line in the diagram. Remember, like when other subtypes exist, when and they're not available in the diagram, but we know that they exist, that is an example of partial specialization rule. With total specialization, we have only specific types of supertype that, and there is no other types exist outside of the diagram. Okay, so let's look at partial or total specialization example. Let's look at this scenario. And we need to identify whether it's partial specialization or total specialization. In the retail management system, product represents all items available for sale. As the system evolves, management decides to introduce more refined categorization to streamline inventory management and sales. Consequently, product category branched into distinct subcategories such as electronics, clothing, and home goods. No other product categories exist. This is an example of total or partial specialization. I'm gonna pause here and let you guys think a little bit. This This is an example of total specialization. And the reason why it's total, because it specifically states no other product categories exist. So product is a supertype that has electronics, clothing, and home goods as subtypes. Let's look at another example. So the next example is also we need to identify whether it's total or partial specialization. In library management system, database initially includes broad category of known as books, which is supertype, encompassing all material available for borrow. With the evolution of the system, the growing need of efficient organization, management implemented more detailed categorization structure. All library books divided into three distinct categories: fiction, nonfiction, and reference. No other subcategories exist. Is it partial specialization or total? All right, so this is an example of total specialization because we have this phrase here, no other subcategories exist. And again, guys, it's very broad description, but you just need to find pieces of information that are needed to answer specific questions. In this case, this last sentence specifies that it's total specialization. All right, so let's look at another example. In a customer relationship management system, database initially had broad category known as contacts, encompassing all individuals and organizations maintained by the company. As CRM matures, then there is a need for more detailed segmentation. Management decided to implement subcategories such as customers, leads, and partners. However, the database retains the option for contacts to exist outside of these subcategories, allowing for flexibility and data management. So we have a supertype contacts with subtypes customers, leads, and partners. However, it states the database retain an option for contacts to exist outside of these subcategories. So there are other contacts in addition to customer, leads, and partners. That means that it's partial specialization because other types of sub types exist. Okay. So, in addition to partial and total specialization, we're going to talk about completeness constraint. Completeness constraint is very deeply connected to total and partial specialization. So there's two different constraints. There is a disjointness constraint that has two different rules. Disjointness constraint states whether an instance of a supertype can be a member of two or more subtypes at the same time. So anything greater than one. And disjoint rule states that an instance of a supertype can only be one of the subtypes. And overlap states that an instance of the supertype could be more than one subtype. Completeness constraint, disjointness constraint, and two different rules, disjoint rule and overlap rule. Let's look at the examples. So, example of disjoint rule. Patient can be outpatient or resident patient, but not both. So patient cannot be resident and outpatient at the same time. That means this is an implementation of disjoint rule. So the patient can be either outpatient or resident patient, but not both. And disjoint rule is specified by letter D in this circle in entity relationship diagram. And again, as we know from a couple of previous slides, patient has total specialization. So there is no patients other than outpatient or resident patient exist. Okay, so that's a disjoint rule. Overlap rule is applied to our part example. So overlap rule means that an instance of a supertype can be more than one subtype at the same time. For example, here part can be both purchased and manufactured. So in this case, it's an overlap rule when an instance of supertype part can be both of subtypes, manufactured part and purchased part. So we put letter O to specify overlap rule. All right, moving on. We're gonna do a couple of examples. Disjoint, we're gonna identify whether it's a disjoint or overlap rule. So, but first, we're gonna practice something we practiced before. Can a person belong to any categories than employee, alumnus, and student? So what kind of situation is here? So if we look on the diagram, we can see that person has three subtypes: employee, alumnus, and student, and we see letter O here. So letter O tells us that the person can be employee and alumni at the same time, or employee, alumnus, and student at the same time. So the answer to this question is yes, because there is letter O in the circle. That means it's overlapped rules. That an overlap rule means that instance of supertype can be more than one subtypes. What are alumni subtypes? So let's look at alumnus, and we can see that it has no subtypes. So there's no subtypes for alumnus. Next question. Can person be employee and student at the same time? Well, let's find a person. So we have a person, and they're asking us if person can be employee and student at the same time. The answer is yes. So because of the overlap rule, when the instance of the person can be employee and student at the same time. Guys, I think I explained you question 1 incorrectly. I apologize for that. Multitasking is never good. I was trying to look at student sending me text. So for question number one, can person belong to any categories other than alumni, employee, alumnus, and student? The answer to this question is no, because of the total specialization rule identified by two lines between person and the subtypes. So if you see two lines, it means that it's total specialization and there's no other person than alumni, student, or employee exists. So the answer to this question, can person belong to any categories other than employee, alumnus, and students? The answer to this question is no. Apologies for that. Question number three we covered. Question number four. What is staff supertype? So we find staff and we find its supertype up is an employee, so employee is a supertype of staff. Can staff be a faculty? Um, well, employee can be both staff and a faculty, so the staff can be a faculty. Can student be an employee? The answer to this question is yes. Student can be an employee because those are both instances of the person, and person has an overlap rule. So in the case of faculty and staff, the answer would be can staff be a faculty? The answer is no, because of the disjoint constraints. So employee can be either staff or faculty or not both. I mean, I know my brain is not fresh today. Sorry, guys. Now, next question. Can student be graduate and undergraduate at the same time? The answer to this question is no, because of the disjoint constraint. So student can be either graduate or undergraduate, but not both because of the letter D here. The staff and have gender attributes. So we look at staff, we look at gender. Gender is an attribute of the person, and person is a super type of employee. Employee is a super type of staff. So gender is an attribute of staff. It's inherited from the person. Does student have salary attribute? Let's find salary attribute, and salary attribute is an attribute of the employee. It's specific for the employee, and it's not a person or subtype or supertype attribute. So student doesn't have salary attribute. Are there employees other than faculty and staff? So we look at faculty and staff, and we look at the employees. So employee has partial specialization rule represented by one line that goes to circle. So in this case, the answer is yes. There are other employees other than faculty and staff that are not included in this diagram. Are there students other than graduate and undergraduate? So student can be graduate and undergraduate, and we look at total specialization rule. So student can be only graduate or undergraduate. There is no other types of student exist. All right, so please practice. Next slide has answers to those questions, so you can check your understanding. Moving on. Now, We talked about subtypes and supertypes. We talked about completeness constraint, and we talked about total specialization rule and partial specialization rule. Now, important concept of extended entity relationship diagram when it comes to subtype and supertype is a subtype discriminator. It is an attribute that determines type subtypes. So in this case, we have an employee type attribute that is called subtype discriminator. It can have multiple values, H for hourly, S for salaried, and C for consultant. So um, similar to the next slide, part has a subtype, supertype entity has a subtype discriminator part type, which can be either manufactured or purchased. And here you answer to the question, manufactured or purchased is why. So key takeaway, each supertype has a subtype discriminator attribute which defines subtypes. And the very last concept that I wanted to touch during our extended entity relationship diagram is entity clustering. So key takeaway here is diagrams are very difficult to take when it comes to many entities. It's very difficult to understand. They have very uh, high data semantics, but since it's a lot of information, sometimes it's very difficult to read. And sometimes we don't need all of those details when we look at the very basic diagram. So we need to make those diagrams look simpler. So for example, this is an entity relationship diagram for Pine Valley Furniture. We looked at that at the end of the last class. And solution for that problem is to minimize entities. And the way we minimize number of entities, we introduce entity clusters concept. In this case, we introduce 6 different entity clusters: selling unit, customer, item sale, material, and manufacturing. And as we look at these diagrams, we can put only one cluster and define relationship between clusters. So let's look at simplified diagram. Looks better, isn't it? Looks more readable, more understandable, and it's better for getting the general idea of a specific model, what exactly we're trying to represent. So entity clustering has advantages: readability, data understanding, decision support, and it's better for communication, specifically when it comes to non-technical communication between different parts of the company. All right. So customer clusters, you can look at here. Then you have an employee cluster, and we're gonna look through a couple of different clusters just to have a presentation on why it's simpler. As in, there is a vendor cluster. You don't need to get into details. It's just the representation of separate parts of the diagrams put into certain clusters together. Now, that's it for advanced entity relationship diagram. Apologies for a couple of confusions during the lecture. If you have any questions, please let me know. Please start working on homework 2. Homework 2 will be based on logical design and advanced entity relationship models. So please put some efforts into getting this homework started. And I'll see you in the next class. And we will, in the next video, we will do an example of advanced entity relationship diagram. I'm gonna draw a large diagram with you guys together so you can look at that as an example for your homework. That's it for today. And